Hello, today we're going to be talking about pointers. In this video, we're going to cover what they are, how to use them, and why we would ever want to use them. Okay, so let's go ahead. What are pointers? Are pointers strings, doubles, longs, integers? Well, they're kind of all of them. So a pointer is just another data type in your tool belt. So it's like a string, a double, a long, an integer. You can just think of it like that. Except instead of storing any of those values, it stores a memory address in your computer. And in that memory address, there could be a string, a double, a long, an integer, or another pointer. So what do I mean by that? In your computer, there are a bunch of blocks of memory that look something like this. And a pointer would point to any of those blocks of memory. So every time you make a new variable, like let's say numer equals 5, 5 is stored in one of those blocks of memory. And a pointer would be initialized to that point in memory. So let's call this pointer 1. And let's say we have another int here that we declare, and we'll call it int k, and we'll say k equals 10. And we'll store 10 over here. And we want pointer 2 to point to 10. Excellent. Now let's say, okay, we don't want numer to equal 10 anymore. We want to set numer to equal 5 anymore. We want to set numer to 10. So what's going to happen now is because numer, the variable numer, is stored in this memory location, it's going to change this value here to 10. And that means that the value stored in pointer 1's memory location is now 10, and these two values are equal. Let's take a look at how to use pointers in action. Okay, so here we have our variable numer, which is of type int declared, and it is storing a value of 5. So that means that that value of 5 will be stored in the memory address that has been given to numer. So when we run this code, it should just go ahead and print out 5 for us. Down here, 5. Excellent. Okay, now let's say we want the actual memory address of numer. The syntax for doing this in C++ is to put an ampersand, the little and symbol, in front of a variable name. And then we can print out the address. So this will print out some random jumble of numbers that shows us the exact memory address of numer. Okay, excellent. Now let's say we want a pointer. To declare a pointer in C++, you're going to have the type that the pointer is going to be pointing at, an asterisk, and then the variable name of the pointer, just like that. Okay, and we are going to also print out the pointer down here, and the pointer is uninitialized at this point. And because the pointer is uninitialized, it's just giving us the address of the pointer and a value of 0 because it's not pointing to anything. So let's say we want to set the pointer to the value of numer. We could try to do it like this, right? So let's go ahead and see if that works. The reason why this doesn't work is because this pointer is of type pointer and numer is of type int. So when you do this, it would be the same thing as saying, or trying to compare a string and a double. They're just two different types and you can't compare them in C++. So the way that we fix this is we pass the pointer the address of numer. Now both of the values at the top over here with numer and then the address of numer, and down here with pointer and then the address of pointer should be the same. So let's go ahead and run that and see if that is correct. That is not correct. Here's why that is not correct. So here, this is printing out right now. This is printing out the address that is stored in pointer, which is the address of numer. And down here, it's printing out the address of pointer. So to get the actual value stored in pointer, which is 5, we're going to go down here and replace this ampersand, which was getting the address of pointer, with an asterisk, which will give us the value of numer. So now these two should be printing out the same thing, except in a different order. So it'll be 5, then the address, then the address, then 5. Excellent. Down here. So we see what the pointer is doing. The pointer is getting the memory address of numer and storing it. Okay, awesome. Now, why would we ever want to use this capability? It just seems kind of silly and there's like a lot to write. You could just like ampersand. Okay, so we're going to look at the first example of when we would want to use this. And that is in the case of functions where we'd want to pass by reference or pass by value. So let's go ahead and take pass by reference down here and pass by value and then pass by reference right here. And for the pass by value, we're going to pass in pointer. For the pass by reference, we're going to pass in the pointer, and for the pass by value, we're going to pass in numer. And you see in both of these functions, we're doing the same thing. So this one is taking an integer as its parameter for pass by value, and it's setting that integer's value to 10. And over here, it's taking the memory address of a value, so the pointer memory address, and setting the value at that memory address to 10. So we're going to run both of these and look at the different results. If our goal is to set numer to 10, we'll see how both of these work. So we're going to print out numer. We're also going to print out numer down here. Okay, so the last two is what we're looking at, or are what we're looking at. So for the pass by value, you see that the value of numer out here didn't actually change. Well, one way you could have made this work is if you returned a numer, but if you want it to not return anything, or if you just wanted to mute the value, this doesn't work here because you're changing the value of this parameter that's passed in, but it's only passing in the value of 5. It's not passing in the actual variable. While with pass by reference, it's passing in the actual address, and it's taking the address that was stored at the one for numer. It's taking 5 and it's literally deleting that value and changing it to 10. One other case where we might want to use pointers is in relation to a linked list. So linked lists are basically a bunch of nodes connected together with pointers pointing to the next node. So a linked list has a head and then a bunch of nodes. And the way we usually iterate through linked lists are by going to the head and then like head.next, which would take you to this node, and then node.next. And in a linked list, you can't go backwards. So what you're going to want to do with a pointer instead, if you had a function where you wanted it to return the head node and change some stuff in the middle, you'd have a pointer that points to the head node, and then it goes to the next node. And let's say you wanted to delete 1. You would say node.next equals 2. So then it would just delete this node from the function, and then when you return the head node, it would give you this value. Whereas if you'd gone through with the head to the end, it would just return node 2 when you return head, unless you had a dummy head, which would be another pointer. But these are just 2 of the applications of pointers. There are many more, and I'll cover those in a future video. Thank you for watching, and if you found this helpful, remember to drop a comment and like. Good luck with pointers.